it's like that. All right, working with Pig. All right, so Pig is a SQL-like scripting language, right? So just like any other scripting language that you've seen before, whether it's C++, whatever, Pig is just like that. So Hadoop Pig, Apache Pig is a platform for analyzing large data sets, right? So basically when you have gigabits or terabits of data that's structured or unstructured, you can use Pig to give it a structure and then data mine it. All right, so that's what makes this really kind of cool. It's a very high-level language, and it basically expresses data analysis programs. Right, and then you have to have the infrastructure, and that's where Hadoop comes in. So you've got Pig, which is your scripting language, but then Hadoop, which is the way of distributing this across a large number of different computers. Right. The salient property of Pig is that the infrastructure is amiable to substantial parallelization. In other words, how Hadoop works is that you have this big data chunk, and then you actually give it out like little chunks of data to other computers to process, and that other computer will then return the results. And the master computer keeps track of where all the packages are across the whole process. So it actually busts it up into smaller digestible chunks that you can actually throw about through the infrastructure that you design, right? And this makes it really easy to handle large data sets. All right, Pig infrastructure at present time today is really kind of small. It's only relegated only to what's called a MapReduce program. In other words, I have a big chunk of data, I've crawled the internet, and now I want to make that data usable to someone else. Right? You can actually go ahead and use this for things like data mining, protein folding, whatever is amiable to being a large data set and broken into small chunks. SETI at home is a perfect example of this, but it's a different style. It's more like distributed computing rather than having a master-slave relationship like you do in Hadoop. Right? Pig actually stands for Pig Latin because it's like pseudo SQL-like, right? So it's really easy to build stuff in Pig, because it relies on very few things. It's more like a meta language than an actual programming language with all the subtle nuances that go in it. As long as you understand a little bit of SQL and regular expressions, you can literally parse anything on the face of this planet. Right? Optimization. This process actually allows you to optimize how the tasks are executed by using that master-slave relationship when you're building out your Hadoop infrastructure. So you have one computer that's always on, all right, and that's your master. Then you have a bunch of little slave computers that go on and go off depending on how much they've done work or how much work they have left to do, right? And you can actually then go ahead and just create your own functions to do this depending on what kind of data you've got to process. So if you're doing banking transaction data, if you're doing things like with the New York Stock Exchange, this is how they're getting those second by second, millisecond trading kind of things, is by building out these kinds of infrastructure, right? Battlefield operations also. Right? When we go into AWS, you're actually going to be using Pig, and we're going to be using their sample Pig script, which is in the classroom, and then they give you a sample data set to work with, and we'll use that first. But then we also have our data that we've been collecting in our S3 buckets. Right? So make it actually really kind of cool. Right? There's two execution modes: local mode, right? To run Pig in local mode, you just need to access a single machine. All the files are installed and using your local host and file system. Really simple. Right? It just says everything's on this one box and this is how I'm going to do it. But what we want to do when we do this, we're going to do this in the MapReduce mode. Right? You need access to the Hadoop cluster that we're going to build. Right? And then the MapReduce mode is default, but you don't need to specify it by using xflag. If you don't use xflag, it will automatically assume MapReduce mode. If you use the xflag, it will automatically assume that this is the only box I'm using for this. Two operational modes, interactive and batch. You can run it in interactive mode, so you actually have to give it responses back and forth, or batch mode, just let the thing run. We're going to run this thing in batch mode. Right? There's no sense in sitting there poking a button every time it wants to go do something, send a new packet. Right? This is where computers were designed to do work, and this just makes them a little bit more efficient and takes out the human operator portion of it. Right? Two types of job flows. Again, interactive mode, where a customer can start a job flow to run Pig scripts interactively directly on the master mode. Right? Usually you do this if you want to do ad hoc data analysis for application development. If your developer comes up and says, how does this user feel about this, you can actually data mine for that specific user, but you have to start poking things in. And batch mode, everything's stored off in S3. You know where all your data is. Your data is consistent. It's like an Apache log consistent. Right? And then you just let it go do its parsing and whatever it wants to do, and you're pretty well good to go with that. Sample Pig script. So the script that you've got in your classroom basically sets up various functions, and we're going to walk through each one of those functions as we go. Right. So first what we want to do is we want to register stuff. There's a whole Java process behind this, right? So what we want to do is we're going to go and evaluate strings, and that's what the evaluation.string is all about. So we want to evaluate by extracting the string, formatting the string to the specific way we want it to look, replacing that string, and then adding and fixing date time. Because date time is always going to be different. We want to make sure the date time stamps match up on this. So we're going to pull the date time stamp out and format it. So we're going to extract the data we want, we're going to format it, we're going to put it back in place in the logs, then we're going to take the date time and we're going to format date time so it actually works the way we want it to work. Fun. Alright, so sample pig script. We're going to import those logs and break them into tuples. Does everybody know what a tuple is? Alright, so a tuple is basically a row in data. Alright, so it's one line of row. That's it. That is a tuple. A tuple can also be broken into that row and column intersection, right? So you have a row of data, you have a column of data. That intersection is also a tuple. It depends on which database person you talk to. For this case, it's that one place where they intersect. All right. So we have raw logs. We have raw logs in our bucket. So what it does, it goes and loads text loader to load all those logs in. Right, it has a log space for each web log string. For each row, we convert that web log string into a structure with named fields. Right, and how we extract that is through this. So we pull the raw log, we generate, we flatten that log out so it's just text, and then we want to extract what each line should look like. And that's where this regular expression comes in place. This whole long line string of stuff is what's called a regular expression. And this is a very standard regular expression for exploding out an Apache log into a nice table-like format to suck into a database. You will see this a lot when you're dealing with data of any kind, especially for logs. It has to extract it and put it into a format so that everything lines up. All your dates line up, all your URIs line up, all your IPs line up, all your destinations line up, and all your objects line up. Without it, Apache logs will sometimes not do a full complete line. Sometimes it will just do a date timestamp because it wanted to test it. Sometimes it won't write anything because it's feeling cranky. This allows you to kind of move this thing around. And what it does by extracting it, it does this as a remote address, as a character array, a remote log name as a character array, a user as a character array, right? So it makes all these arrays for all the things you want. User, time, request, status, right? It turns into an integer, byte string, and character array, the refer, who sent it, and then what browser they were actually using as a character array. So tuple. In mathematics, computer science, tuple, ordered list of elements. So everybody remembers set theory? You have a bracket and you have 1, 3, 5, and 7. That's an ordered bracket in math. And that's about as far as I'm going to go with this, right? Right? Because math, we should know some of ordered set lists because we use those a lot. An array is an ordered set list in a lot of ways, or an initialized ordered set list. We just haven't used it yet, right? But they're used to describe mathematical objects. If you go into game design and engineering, you'll see things as an ordered array like a vector, right? Vector graphics are all an ordered array. Because you're in computer science, tuples are directly implemented as product types, right? Character array, byte, integer, all that other kind of good stuff, right? Components are labeled instead of being identified by position alone. So position doesn't matter. We just want to have this little chunk of box that has all this stuff in it, right? Also, everybody love relational algebra? Huh?
Yes.
Yes, we do. So this is the regular expression that busts everything out, right? So this is what parses out that data. We bring it in, we flatten it, and then this is how we chop it up, right? The one thing about pig is that it requires the extra escape character. So if you look at the extra escape character that's right here, these are the extra escape characters. Pig won't play nicely without it because pig is still an interpreted language, right? So it has its own little happy horse things, right, to go along with it. So because of that, pig is very similar to SQL. If you have an SQL regular expression that your database guy has done, then you can actually bring that over into pig. You just have to remember that extra escape character along the way, right? Use in AWS. So this is a little hard to read because of the line wrapping, right? Right? So what you should see is that pig is loading the line into the tuple, right, our single element, right, the line itself, and now you need to split that line into field. To do that, we use the extract command, piggyback function, which applies to the regular expression. So that's how this all works. So if we bust out of this and we take a look at our script, this is exactly what it's doing. It registers the jar because that's what we want to use, right? Then it pulls the raw logs, imports, and does its whole thing. So the raw logs load input using text loader, right? So text loader function in Java. Then for each weblog string, each line, convert that weblog string to a structure with name fields. And that's exactly what we want to do. And that's exactly what this chunk of code does. Just imports and breaks it into tuples, ordered set arrays of whatever we want to do with this. So it kind of makes sense? Okay. You had a question, ma'am.
The time. So in the scripting where you're implementing the time, are you putting, like, say you're working with 2 different time zones, are you putting in the time zone of the endpoint of where it's going, or how do you...
You're converting the timestamp that's actually in the logs. That's all you're doing, is converting it over to a much more readable format.
Oh, okay.
Yep. You had a question, sir.
More request. Can you take the mouse and use the mouse to show where those
Not if I want to leave it in PowerPoint presentation mode.
Because, watching the video, we can't see you pointing at the screen.
No, I know that, but I could do that, but again, I have to be out of presentation mode to do that. All right, so again, we bring this in, we tear it all apart, and this is the final script segment for just converting the logs. That's all we do here. All right. Then for each, we want to convert string values to type values such as date, time, and integer. So for each logs base, we want to generate the date, time, and we want to put it into a format as time, date, month, year, hour, minute, second, and then we want to take it as universal coordinated time. So it's all going to convert it over to GMT. All right, and we love the British, so GMT is 8 hours off from here, right, as a date time, and then replace all that within the logs itself. All right, so then determine the number of requests. This is where we actually get the computer to start doing stuff. Now it's formatted everything the way we want it to be formatted, right? We want to determine the total number of requests and bytes served by each hour of the day, aggregating as a typical day across that entire time frame of logs that we have. So we'll have like 7, 8, 9, 10 weeks worth of logs to play with. So they will just go ahead and give you an hour count as an average across that entire time span. Right? And so we group logs by their hour of the day, counting the number of logs in that hour. So if you have 5 logs in hour 1 and 20 logs in hour 6, right, it will give you a graph of 1, 0, 0, 0, 0, 6. Right? So, and then the sum of each byte's a row for that. So basically all it's doing is counting. And that's all it's doing, counting and then summing it. If we just wanted the raw count, we could take out this line of sum right here. Right? If we just wanted a sum, we still have to leave the count in there, because the count is how it's going to sum off of and average all this stuff. And then store by hour count into the output as total request bytes per hour. So we have an output file that this is going to be dumping to into your S3 bucket as well. All right. So then we can do more sorting, like top 50s, right? Everyone's interested in who's the top 10, who's the top 20. You can change this into a top 10 or top 20. But top 50 IP blocks, it's going to rip out the IP address and then count those exactly like we counted the bytes sent per hour. Exact same kind of thing. But we have a different regular expression here, extract D+, with the extra escape character in here. What that does is normalize and looks for that IP address as a set of octets, right? So it's going to be looking for this octet here, dot octet, and it will ignore one set of those 4 octets that we're going to be dealing with.
Is it specified on what octet it's ignoring?
It will go, this will give you A, B, C. This will give you a class C address. Right, so instead of, if you wanted the entire class D address to see if someone kept on coming back, you would just add an extra dot //D plus to this. But this will just give it to you by class C. All right, and then it counts it and it sums it, and then by IP account, order by the IP number of requests they make. So it takes that number that we had before, how much stuff we sent, and then orders it by the IP address. So if we have one IP address that's standing out like a sore thumb, what are they doing? And then we can go back into those logs and just extract for that single IP address alone, and then figure out and see if they were doing something nefarious to our S3 bucket. Then refers. We always want to know who sent data to us or who sent someone our way, especially with the S3 buckets fairly private, and we don't really think anyone should be getting in there, right? So the top 50, if we have external referrers like Google or Bing, then we set our buckets up wrong, but we can extract out and figure out who's referring to us, that particular data chunk. So when you see this, it's going to extract out by HTTP, and this is a fairly standard way of validating that this is a valid .com, .net, .org address. So this is the regular expression you're going to see a lot for validating that this is a valid URL. All right, and then we flatten it, we count them, and then refer, count, filtered, then limit order, top 50 results. Anything after that we don't care about, and then we're done. All right. Then we can also do this thing for searches. We can do this thing for anything else that we can do with that data. Right. So this is the same kind of thing. Brings it in, refer matches Google or Bing. Then we just want to see who from Google and Bing are hitting us. Where did we get that from? And this basically busts this out even more to look for Google and Bing URLs. So if referrer matches Google or referrer matches Bing, then we want to split those out even more and get another table on that. Right? Note the use of regular expressions. Group logs by extract refer. HTTP validation, make sure it's a valid com. Group logs by format, extract remote address. This is where we're pulling the actual IP address out of the system. Right? Flatten, extract, refer as a character array. This is how we validate that the refer is an actual good line of code, that it will match up with either a Google, a Bing, a Yahoo, or something else. So regular expressions are a real pain in the butt, but once you get some regular expressions down, your ability to script is just going to go right through the roof, because now you know how to slice and dice data. Right? This means absolutely very little to anybody else on the face of the planet. But regular expressions are a really good way of helping you slice and dice data. Right? Quick and dirty regular expressions cheat sheets. If you want, there's one out at OWASP, and there's a really good site called regularexpressions.info, and you can just literally lift that out and put it into your pig script. You just have to remember that extra escape character, and then you've got it. So there's no point in busting your head trying to figure out, how do I do this? If you want a regular expression for a social security number, go out to regular expressions, drop it into your pig script, and add that extra escape character, and you're done. Okay, questions? Are we good? Was that exciting? Did you guys like Pig? Is Pig awesome?
Pig looks very neat.
Pig is actually really kind of cool.
What's the output look like?
The output from the actual program?
Yeah.
It would just look like a table order structured list.
Just be a table.
Yeah.
When was Pig established?
About 2 years after Hadoop. So Hadoop came out in like 2003, 2004, 2005 based on a white paper from Google. And Pig, we needed to figure out a way to slice and dice the data once we got all this stuff up. So there's actually 3 different programming languages for Hadoop. Pig is the easiest in terms of the familiarity of the whole thing for you guys. But you can just program raw in Java, you can program in something called Hive, which is a pain in the butt, or you can program in Pig, which is more SQL-like. And it's something that system administrators are going to be able to deal with a lot easier than Hive or actual programming in Java and making your own custom apps. So any other questions? Are we good? Pig awesome?
Yeah, Pig's very neat. I
Pig.
look forward to it.
Very cool.
All right.